In part B, we're going to look at 4 different angles and do the same 4 things to each of them. For the first one, we're going to let alpha equal 45 degrees, and in part A, we need to graph it in standard position. Standard position is going to mean the initial side is always going to be the positive x-axis, and the terminal side is going to make that 45-degree angle. Well, 45 is halfway between 0 and 90, so it'll be in the first quadrant, and split the quadrant in half. Then we should also put this arc in here to signify that that's the angle that we're talking about, not the very obtuse one. In part B, we want to identify the reference angle, and that's going to be the angle that the terminal side makes with the nearest x-axis. In this case, it's going to be the same. This is a first quadrant 45-degree angle, so its reference angle is 45 degrees. A coterminal angle is going to be an angle where the terminal side stops in the same spot. However, it has a different angle measure. So what I'm going to do is to take the terminal side of this angle and rotate it one more time around the circle. So if we start at the 45 degrees and add one more trip around the circle, we'll end up with 405 degrees. And 405 is one of infinitely many coterminal angles. The last step is to convert this from degrees into radians. And this is one that's on our radian snowman, one that we should be very familiar with, and we should just know that it's going to be pi over 4 radians. Next, we're going to let beta equal 110 degrees. So to graph it in standard position, the initial side is always on the positive x-axis. Now the terminal side, if we rotate this far, we'll end up with 90 degrees, so we need to go a little bit extra, just another 20 degrees past that positive y-axis, which puts us about right here. Again, we should make our arc go all the way from the initial side to the terminal side, signifying that that's the angle that we're talking about. To identify the reference angle, we want to see what angle the terminal side makes with the nearest x-axis. In this case, this is the angle we're talking about. So the terminal side of the angle is at 110 degrees, and we want to see what it makes with the negative x-axis, which is at 180 degrees. So the difference between those two is obviously 70 degrees, making that the reference angle. So another way to look at this is that 110 degrees is a 70-degree angle in the second quadrant. Coterminal angle, again, we simply take the angle that we started with, the 110 degrees, and I'm going to spin the terminal side around the circle one more time. So I'll add 360 degrees, making the coterminal angle of 470. Last one is to convert it into radians. This one's not on our radian snowman. So we're going to start with 110 degrees, put it over 1, and now multiply it by pi over 180 degrees. The degrees are going to cancel, and we'll have a fraction of 110 pi over 180. Simplifying the fraction, that'll make 11 pi over 18. Next, we'll let theta be 4 pi over 3, making it an angle measure in radians. Still, if we're going to graph it, the initial side is on the positive x-axis, and our terminal side now has to go 4 pi over 3's around the circle. I always think of an angle like 4 pi over 3 as being 4 pi over 3's. And then a pi over 3 takes the top half of the unit circle and divides it into thirds. So that would be 1 pi over 3, 2 pi over 3, and 3 pi over 3 brings us over to 180 degrees, or pi. So to get to 4 pi over 3, we're going to be the pi over 3 angle in the third quadrant. So the terminal side of the angle will be right here. And of course, we should put our arc to signify this is the angle that we're talking about. The reference angle is going to be the angle that the terminal side makes with the nearest x-axis. In this case, this is the angle we're talking about. Since our terminal side here is 4 pi over 3, and now looking at the negative x-axis in terms of radians, that's pi. Now, to find the difference between these two angles, we start with the larger one, 4 pi over 3, and subtract pi, which is 3 pi over 3. That difference is, of course, pi over 3. I like thinking about this is that 4 pi over 3 is the pi over 3 angle that is in the third quadrant. To find a coterminal angle, again, we're going to take the terminal side and spin it around the circle one more time. In terms of radians, that's going to mean that we start with 4 pi over 3 and add one more trip around the circle. In radians, a trip around the circle is 2 pi, or 6 pi over 3. So when I add these two together, we'll get 10 pi over 3 as a coterminal angle. And then finally convert it into degrees. That means we'll take 4 pi over 3 and multiply it by 180 over pi. The pi's will cancel. 3 goes into 180 60 times. 4 times 60 would make 240 degrees. Last one, negative pi over 2. To graph it, our initial side will be the positive x-axis. Since we're going to be negative, that means we got to go down pi over 2, which means down to the negative y-axis. Instead of an arc this time, because it is a right angle, put the little square right in the corner. The reference angle is the angle that it makes with the nearest x-axis. In either x-axis, this is a right angle, which is 90 degrees, but remember, we're in radians, so we should write it in radians as pi over 2. A coterminal angle means we'll start with that negative pi over 2 and add one trip around the circle. We'll add 2 pi. Well, 2 pi is really just 4 pi over 2. Adding these two together, we get 3 pi over 2, which we kind of knew looking at our radian snowman. Finally, converting negative pi over 2 into degrees. Well, we know pi over 2 is 90 degrees, so since this is negative, it'll just be negative 90 degrees.